In the last video, you saw EDA as one of the most important parts of the data science process and where data analysts spend most of their time. Sometimes it is difficult to analyze and derive insights from very large datasets due to the very time-consuming and resource-intensive nature of the activity. In such situations, you are forced to work with a smaller section of the data instead of using the entire data. Remember how your mother determines whether the rice for dinner is cooked or not? She tastes a few grains of rice to check its texture. If it is chewy and hard in the center, she adds a little more water and cooks it for a few more minutes. This is an application of inferential statistics. The process of inferring insights from a sample, making reasonable estimates for the entire population, and using those insights to make further decisions.
Now, let's extrapolate this very homely example of inferential statistics to a business example. Now, it's a complete coincidence that the second example is also about something we love, eating. Remember when Maggi was banned in India after a food safety regulator sued their parent company for selling noodles containing excessive lead and the flavor enhancer MSG? The permissible limit on lead and MSG is 2.5 parts per million. Initially, the company claimed that it was indeed following the regulations, i.e. noodles did not contain more than 2.5 ppm of lead and MSG. Now, why and how was this claim rejected?
In order to test such claims, we use a method known as hypothesis testing. The original claim which the company makes, the average content of lead is at most 2.5 ppm, is denoted by the term null hypothesis or the status quo. The inverse claim that it contains more than 2.5 ppm is called the alternate hypothesis. The reason why the noodles were banned was that the tests conducted on the samples in several laboratories concluded that it contained dangerously higher levels and therefore the company's claim was rejected. Here you must be wondering, how are these tests conducted and how do we make those decisions? Well, let's hear from Professor Tricha from IIITB as she explains this process of getting samples to test your hypothesis for a similar scenario.
Suppose a company called Quick Foods files a complaint against Sunshine. Its competitor, that Sunshine's ready-to-cook pasta contains excess quantities of lead. So you take 100 random samples from the market of Sunshine's pasta and have them tested for the amount of lead. The mean lead content turns out to be 2.6 parts per million with a standard deviation of 0.6. What do you conclude from this test? Should you raise a regulatory alarm against Sunshine?
In this course, you will learn how to scientifically use data to conclude whether to reject the null hypothesis or not. One of these methods is called the p-value method and is a fundamental concept a data scientist must have. Here is a clipping from the upGrad data science course where Ms. Kalpana, ex-AVP GenPact, speaks about making business decisions in the industry with the help of hypothesis testing.
And the important aspect of that is, you get to understand the relationships between the variables and if they are significant relationship. It also helps you to some extent in your reduction in the number of variables that are going into your final model development. If there are insignificant variables, if there are no relationship between your variables, you could leave them out of your analysis and you could continue with the ones that are having a significant relationship.
While hypothesis testing is a very useful method to test a scenario and whether it may be true, there is always a small possibility that we wrongly reject a claim, that we are incorrect in our inference. Don't worry, this small possibility can be measured and is very commonly reported by data scientists along with their hypothesis test results as errors. These errors are called type 1 error and type 2 error. A good way to think about this is in terms of a typical movie situation. An innocent hero is sometimes put behind bars for a crime he hasn't committed. This is an example of type 1 error and in technical terms called rejecting a true null hypothesis. In another movie situation, a criminal villain may roam around freely. This would be an example of type 2 error and in technical terms called failing to reject the null hypothesis when it is in fact false.
We talked about the intricacies of inferential stats and hypothesis testing with the noodles example, but what does an application of the hypothesis testing look like in a business setting? Let's say your company wants to increase sales by funding a new marketing campaign. You, as a data scientist, would recommend that the company run this campaign initially in one region of the country to observe its effect. Remember sampling? You will then use the data thus collected to measure whether the campaign has had the desired level of effect. Remember hypothesis testing? Your company can then decide to launch the new campaign nationally if it believes that sales will rise by more than, let's say, 25%.
The best way to become a data scientist is by solving case studies. Working on real world problems will give you a strong flavor of a data science job. The problem most banks face today, which is customers being unable to repay the loan they have taken, causing losses to the bank. This problem in the banking and financial services space is typically solved by minimizing the likelihood of lending money to a risky customer. With this case study, you would develop the basic domain knowledge of risk analytics and use your EDA skills to identify risky loan applicants. Risky loan applicants, once identified, are typically rejected for their loan application, thus saving money for banks. You would get your hands dirty with 4 major categories of customer information: customer demographics, loan information, customer past behavior, and application information. This will be used to study their impact on loan default. You would be using Jupyter, an interactive computing platform, and Python to write scripts to explore the data and generate insights, mine patterns, and draw conclusions on loan default behavior.
Now that you have successfully understood the first 2 steps in the data science lifecycle, EDA and statistics, you will get to know about supervised learning in the next episode.